Hello students, this is part 2 of the graphing sine and cosine functions video. In this video, we will look at different transformations of the sine and cosine functions. By transformations, we mean vertical stretch or shrink, horizontal stretch or shrink, vertical shift up or down, horizontal shift right or left, also the reflection across the x-axis or y-axis. The good thing is that these transformation rules are very consistent in every function family. So right here, we have two equations, and we call these sinusoidal functions. One is for the sine and the other is for the cosine. And notice that this is the standard form. You have some parameters here, which we will talk about how they impact the graph. And there is another version of this equation, which we will talk about when we will discuss the phase shift. So the other version is where B is factored out of the equation. So B will be factored out from this factor, Bx minus C, and both in sine and cosine. So let's talk about the parameters. So let's first discuss A. A is considered to be, which is A is the leading coefficient, is considered to determine the amplitude of the graph. If we take the absolute value of A, this gives us the height or the amplitude of our sinusoidal function. The amplitude is the distance between the midline and the maximum value, or the midline and the minimum value in both sine and cosine graphs. And since it's the height, we take the absolute value of A because the height is not negative. Also, if you see a negative before your leading coefficient, then that will have a different role. It will make your graph reflect over the x-axis. So right now we are talking about the amplitude. Amplitude will be the absolute value of A. If the absolute value of A is greater than 1, it will make your graph vertically stretch. And if it's less than 1, it will be vertically compressed. The value of B determines the period of the graph. If B is 1, then the period of your graph is just 2 pi. But if B has a value other than 1, we calculate the period by using this formula 2 pi over the absolute value of B. We take the absolute value of B here because, again, B could also be negative, which causes the graph to reflect over the y-axis. So you have to remember the A being negative means your graph will reflect over the x-axis, and if your B is negative, your graph will reflect over the y-axis. The value of B here has a different impact than the value of A. If B is greater than 1, it will actually make your graph horizontally compress. And if it is less than 1, it will make your graph horizontally stretch. And you can easily remember this because you're dividing. If you divide a number by a number greater than 1, that makes your output smaller. So your period will be less than 2 pi. And if you divide it by a number less than 1, it will make your output bigger and your period will be more than 2 pi. The phase shift formula is C over B. In fact, negative C over absolute value of B. Why negative is, hopefully you remember from other functions like quadratic functions and exponential log functions, that if you see a minus, that actually with the x, like x minus a number or x plus a number, it has a different impact. The x minus makes your graph actually reflects, shifts to the right, and plus makes it shift to the left. That is because conceptually, if you understand it, you have to take if it's a minus, you have to take a bigger number to get the same output, and that makes your graph shift to the right. But anyway, a lot of times students just memorize that if you see a minus with the x in the x factor x minus, it goes to the right, plus goes to the left. And also in the formula, if we have a negative here, that will give us the phase shift. If it's a minus, it will give us a positive value, which means the graph will shift to the right. Here, I want to mention that there's another form of equation that we use. And just write this here. Which is sometimes you will see, like I said before, the B is factored out. If B is factored out, then you don't have to divide by B anymore. Then this C is the phase shift. Okay, that applies to both sinusoidal functions, which means sine and cosine. That the phase shift will be just this negative C, or just change the sign. If it's a minus, then it shifts to the right. If it's a negative, it shifts to the left. Last parameter is D, which does the vertical shift up or down. It also gives you the equation for the midline of the graph. Midline is the line about which the graph oscillate. So midline is equal to, I'm going to actually write y equals to D. So let's look at few examples here, and we're going to just practice identify these values of amplitude, period, phase shift, and vertical shift based on the values of A, B, C, and D in the sinusoidal equations. So first I have here A is 3, B, there's no coefficient that we see before X, so it's 1. C is pi over 2, D is 1. So the amplitude, which is the absolute value of A, is 3. Period, which is 2 pi, divided by the absolute value of B, is going to be just 2 pi. Phase shift, which formula for which is negative C over absolute value of B. Negative times the negative pi over 2 will just be pi over 2, or I can say pi over 2 to the right. And then the vertical shift is shift up 1 unit. So D is equal to 1, or you can just say it's D, so it's just 1. Okay, I'm going to pause the video here and let you answer part B the same way that I first identified A, B, C, and D, and then based on that, I determined the amplitude, period, phase shift, and the vertical shift for this graph. So let's pause here. Okay, so hopefully you had the chance to answer the question. Here, the value of A is 1 over 4, B is 1, C is pi, and D is negative 2. So based on this, the amplitude is 1/4, period is 2 pi, phase shift is negative pi, because it's negative C over B, B is 1, C is pi, so negative pi over 1 is negative pi, and the vertical shift is negative 2, or shift 2 units down. I will pause again and let you answer part C. Okay, so again, let's identify the values of A, B, and C. A is 2, B is 2, and C is pi over 4. So our amplitude is 2, period is 2 pi over 2, which is pi. Phase shift is negative C over B. So negative times negative pi over 4 over 2 is pi over 8. And the vertical shift is 0 because there is no D here. I'm going to also write D is equal to 0. Okay, let's try D. Okay, so A is 6, B is 1/3, C is pi over 6 and d is -1. So our amplitude is 6. Period is 2 pi over 1/3, which becomes 2 pi times 3 over 1, or 6 pi. Phase shift will be negative times a negative pi over 6. I'll just put a negative here. Same thing, I'll just put a negative here. Negative times a negative pi over 6 over 1/3, which becomes pi over 2. And our vertical shift is -1. Here, I want to emphasize one more thing, that we could also, if sometimes the complex fractions become a little difficult for students, so you could also find phase shift by just setting this bx minus c factor equal to 0 and solve for x. So now I will just multiply both sides by 3, and x is equal to pi over 2. Okay. Okay, let's try the next one. Okay, so A is -2, B is 1, C is -2 pi over 3, and D is 0, which means the amplitude is 2, which we have to take the absolute value. Period is 2 pi. Phase shift is 2 pi over 3, positive 2 pi over 3, which means 2 pi over 3 to the right. And vertical shift is 0. All right, last one. Let's give it a try. Okay, A is half, B is 1/3, C is negative pi over 3, and D is -2. So our amplitude is half. Period is 2 pi over 1/3, which is 6 pi. Phase shift is negative times a negative pi over 3 over 1/3, which will just give us pi, and the vertical shift is down 2 or -2. Hopefully this was helpful.